Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. This is the beginning of a two-part episode. First, I'm going to show you this. This is something I made entirely out of scraps. That's things I could find on the shelves in the back office and in and about my garage. And you can see it's a Pelly type box from wonderful safety equipment case, and it was just a standard waterproof type case. It weighs quite a bit now, and you'll see why. And you could tell probably because there's these number plate screw caps on the outside. This was really jank. The backstory is I was asked by my brother-in-law to trace a frequency that was jamming. There's a signal that was jamming his alarm systems, and I didn't have anything that could do it, but I knew from software refined radio experience that I could knock something together. So literally knock this together in about 30 minutes, and I'll show you the components inside it. I'm going to tilt it slightly so you get a better view. Excuse the reflections. On the top here you have a touch screen. It's a TFT touchscreen, and it is blah 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 about 7. I say they'd probably call it a 7.5 inch. It's probably about really more like 7 inches viewable side to side, diagonally. And it's an HDMI screen, and I've got a very flat ribbon type cable that you can buy, an HDMI to HDI ribbon cable. It's going from there to there, and then inside there you've got a Raspberry Pi that has been hot glued. There's a lot of hot glue in this. It's been hot glued down, but it's in a case that I 3D printed. So that way I can still take it out by just undoing the 4 screws and removing it, because of course the SD card is in there. And you can see the power to the Raspberry Pi is provided via this USB, which we're going to leave aside for now. Inside the case as well is a battery bank. So this is one that I had on the shelf for years doing nothing, and it's 3 bars, almost fully charged. A lens cloth, because I don't like dirty screens, especially been touching with your fingers. It's nice to buff them up. And an antenna. The antenna is removable. You can see it was on a magnet to this metal piece of angle line that I'd already prepared for something else and just bolted it to the side. Bit of gate or something. So I just made a hole and just put the bolt on the end, the nut on the end. And then beyond that you can see a software-defined radio TV dongle. So it's actually a television dongle. That's a standard TV RF connector there. And there's a USB here, and that goes to the screen for its touch screen. So what I'm going to do is power it on, and we can see what it does. And I think to do that, I'm going to tilt this that away as I apply the power. Power is happening. It's loading up the full Raspberry Pi operating system. You can see that takes time to boot. It's a little bit painful, but it does get there eventually. And you can see here something called Freak Show, which is an Adafruit piece of software that I managed to coerce to work on this. It wasn't necessarily designed to work on this particular screen Raspberry Pi combination, but I got it working, and that's cool. And it has a touchscreen interface, which is really cool. It's written, I think, in Python or Qt, something like that, but you can modify it if you want to. So one of the tests I had is a traditional garage or gate opener, and you can see nothing going on. That's because, of course, we're not in the right frequency range. So all we have to do, by the way, let me just show you this, it's pretty cool. You've got the frequency waveform there on the top. You can hit switch mode at any time and you'll get the waterfall effect. So if you've used to software-defined radio, you get the waterfall. In fact, excuse the shine on the screen, I'm just going to open the antenna a little bit more because we might get a little bit more interesting stuff to see. And you can hit config at any time, and that will allow you to select the frequencies that you're looking for. So for us, I'm guessing, I think these are 480 megahertz, so we push 480, accept, and then we can go back. And then hopefully, as I'm pushing the button, we might see some effect. In fact, I'm going to go to this mode, because you can often see a little spike on this. You can see the line's quite high up there. There are some adjustments we can get it down here. It's at the moment it's automatically brought it up there for some reason. It's not always perfect. I don't think I'm at the right frequency. Maybe it's 433. Let's have a look. Clear that. 433. Accept. Hit back. And I'm going to push it again. Oh, there you go. You can see it right away. So if I put it into the waterfall mode, so you can see when I push it, I'm going to push it now, and then I'm going to let go. Then I'm going to push it now, let go. now, I let go, and now. There, you get the idea. You can see the signal right there. Technically, it should work for FM, but in the back office we've got this particularly bad amount of interference here, so it's not always clear, but let's see. Let's do 95.8 capital A. We're not in London though, so we're not going to get capital FM, but there you go, you are seeing it. You can see all of the different radio stations here on FM. And if we do switch mode, again, it might not be so easy to see, but there, that auto, I'm not really happy on that. I have to play with this automatic gain control. Gain 10 dB. I'm not always convinced, you see. Oh, that's actually quite good. I'm not always convinced by the gain controls that exist in these TV dongles. I've had really good results from external ones. And that's it. That's all this box does, pretty much. The whole Raspberry Pi now. You could access it over SSH to tinker with it. You could probably load games. So I tend to just leave it like that. Once we've done a little bit of analysis and figured out what we're looking at, just through tinkering with the software. It's crude software, so you do have to manually mess with some of the numbers till you can really pinpoint what you're looking at, but it's absolutely fine for this purpose. All I do is I pop out the USB power, and you can collapse the antenna, which I like to stick in here. Boom. And that's it. Put it away back on the shelf. And I think that's a really neat solution. That works for most things. And if you really want to, you can lock it. If you're curious, this is a pressure release valve. I don't think it has any application in what we're really doing. But maybe you could use that for something. That'd be quite cool power port, wouldn't it? So there, hopefully that's been interesting to you. Please stay tuned though to the next video, and I'll give you a little sneak peek of what we'll be doing in the next video, because I've got the bits here. And what we'll be trying to do is upgrade this, because there are some things that I think it would benefit from. So apart from a software update, so it would be really cool to have a touchscreen SDR radio receiver running. Please comment down below if there's a touchscreen SDR radio receiver software that you think I should try, a Linux-based one. So that way we can put a speaker on here and actually just listen to it, use it as a communications receiver. That's neat. Something else, that TV stick is using that RF stick, which limits it in the SDR world, because most SDR things use these other connectors called SMA, I believe, these type that you've seen on things, which are like a little mini coax. Not too much different from your F connector, just a smaller version. And unfortunately that's really annoying because it doesn't do that. I do have these antennas. You see these are like a TV antenna, another TV antenna with that RF. It's just, I don't want to use that. I'd rather use a different system. So what I'm going to do is remove from this bellon here this connector, and I'm going to be soldering it onto that, and then that way I get to use this very kindly provided to me by GPIO Labs, an LNA, which is a low noise amplifier. In fact, it says it's a LNA, ultra low noise amplifier, and that allows me to apply USB power to here to switch in and off this additional gain, which is really cool. Remember I was telling you about the LNAs built into these things. I don't trust them. If you have this, you can just externally flick a switch and just instantly apply it and take it off if you want. That's no problem. And then of course we have some smaller USB leads. Maybe it's possible to reduce the length, like this touchscreen's really long, and that's probably a better cable, more useful in a different application. So hopefully that's been of interest to you. Stay tuned for a future video on this. Probably the next video might be this. It might be here, it might be there, it might be in the links. As ever, thank you for watching.